So in this video, we want to convince ourselves that SF6 is this molecule polar or not. Well, the first thing we got to do is draw the Lewis structure. And so we know that sulfur, we have 6 fluorine atoms, and we have one sulfur atom. So we know from the periodic table sulfur is oxygen's cousin, so we get 6 valence electrons for that, and we also get 7 valence electrons for fluorine since it's a halogen, right? So we're just counting out the total number of electrons we have to draw. That way we don't miss our Lewis structure. All right, so 6 times 7, that should be 42 if I'm not mistaken. So 6 times 7 should be around 42. All right, and then we have 6 more. So we have 6 from the sulfur. We have 42 electrons from the fluorine and 6 from the sulfur. So total we have 48 electrons. Right, so usually again we know that molecular formulas, their usual central atom is going to be most likely in this case a sulfur, and so at this point we could place our 6 fluorine atoms around this molecule. So I like to just start with single bonds, and in this molecule you should not be surprised that sulfur has more than 8 valence electrons, because it is one of those atoms, or it is one of those atoms rather, that can have an expanded octet. So in this case we have 2, 4, 6, 8, 10, 12 electrons around the sulfur, and we shouldn't be alarmed by that. Right? So let's leave sulfur for now. Each of our fluorines really have only 2 valence electrons around them, so let's try to fill in the fluorine. Let's assume that sulfur's octet is full for right now. So if we assume that sulfur's octet is full, then the only other way we could go about this is actually placing lone pairs on the fluorine atom. All right, and so if we do this, what we're actually doing is giving the fluorine, we're fulfilling that octet rule for the fluorine atom. All right, and so if you look at this, all I'm doing is just putting 3 pairs of lone pairs around the fluorine atom, since it already had two electrons around it from the single bond. And so if you count this up, then you could simply do 6 times 8, and you'll see that 6 times 8 is really 48 electrons. So we know that this is a good Lewis structure for the molecule. All right, and again you can see that all the octets are full in terms of the fluorine. Now if you do your dipole moments, what you could actually see is that, and let me actually, so we know that if our dipole moments go tail to tail, then we know it's a net dipole moment of 0. Right, so let's see what's going on with this molecule. Let's draw our dipole moments. And so if we look at our dipole moments, then we know fluorine is more polar than sulfur. It's more electronegative rather, so it's going to hog the electrons, right? And so we could draw our dipole moment like this. Now you can see that the 2 arrows that we have, those cancels out because they're going tail to tail. The same thing is also true for here. The same thing is also true on this axis, and the same thing is also true on this axis, right? So all our dipole moments cancel out, and so actually SF6 is actually non-polar for that reason. There is no dipole bonds. Also, this molecule is an octahedral geometry. All right, so again, around the central atom, 6 bonding electrons, no lone pairs. This molecule is octahedral. All right, so the plane of symmetry, along with the fact that there's no dipole moments, make SF6 a nonpolar molecule.